Here we are having y is equal to f of x is equal to sin x. Sine of x, graph of sine of x we are having, and see that the natural values for range and domain for sin x is, we know that domain is here. Domain, what is domain? Domain means the x values. X values, you can see x we are having pi, 2 pi by 2, 3 pi by 2 means we are having real values. Okay, real numbers, sorry. So range is real numbers and domain is real number, and range is -1 to +1. Here we are having y values from -1 to +1. Okay, so this is the range and domain of sin of x. So you can see that the graph is lying in between -1 to +1. The graph, all the values of graph lies, it is a continuous graph, you can see, and it lies in between -1 to +1 on y-axis. Okay, on y values. So it is a, and this graph will not goes beyond the +1 or -1 y of y values. Okay, so if you substitute any value of real number in the x-axis, we will get the graph which lies in between +1 and -1. So that's why we are taking range of -1 and +1. So if we are taking sine of pi by 2, we will get +1 value here. We will get +1. If you are taking sine minus pi by 2, then we will get sine minus pi by 2 is minus sine pi by 2. That means -1. Or if you are taking sine 3 pi by 2, sine 3 pi by 2 is -1, and sine minus pi by 2 is -1. Okay, sine 3 pi by 2 is -1. This one is, sorry, here -3 pi by 2 it is. Sine -3 pi by 2 is +1, and sine pi by 2 is +1. Sine minus pi by 2 is -1. Sine 3 pi by 2 is -1. Okay, so that means graph lies in between -1 and +1 values of y or the range. That's why we are taking range is closed interval. Okay, if you are taking any value of x, we will get the graph in between -1 and +1, including plus and -1 values also. So we have to include -1 and +1 values also. Okay, so see here, now we know that to find the inverse of a function, the function must be 1, 1 and onto, bijective or invertible. Okay, bijective means a function which is 1, 1 and onto both. Then we can say this one as a bijective function. So we have to check whether it is a 1, 1 or onto. It satisfies the condition for 1, 1 and as well as for onto. See here, for 1, 1 we are having for x value, domain is here, we are having if you are taking pi by 2, sine pi by 2, suppose this is domain and this one is range, we are having +1 for pi by 2, plus pi by 2. Okay, and for -3 pi by 2 also we are having +1, and for plus pi by 2 we are having +1 value. That means for x values we are having, for different values of x we are having same image on range, same image 1. So that means it is not a 1, 1 function. Okay, because we are having same image for different value of x, then it will not satisfy the condition of 1, 1, or it is not a 1, 1 function. Okay, and what about onto function? It is an onto function because for every value of y, for every value of the y, we are having one pre-image in the x, in the x values or in the domain. For every value we are having, what is onto function? For every value of y, or we will have an pre-image in the x-axis, or sorry, in the x domain. For every value here, for every value of the range or the y-axis, we are having pre-image in the x values. Okay, so it is a onto function. But to find the inverse of a function, the function must be 1, 1 and onto. But here sin x is not 1, 1. It is a onto function. So we have to, but anyhow we have to find the inverse of sine of x. How to find? So we will impose some restriction to range and domain values. So we will fix some values to the range and domain values so that the function become 1 and onto both. Then we can find the inverse of a function. So see here, we will choose some values in this range and domain. We will choose some values so that the function become the inverse. So then the range and domain will have some fixed value. Here range having fixed values -1 and +1, but the domain is having different values. It is a real number. We are having real number on the x-axis, so we are having different values. But we have to impose some, we will make some restriction so that range the function become inverse. To make this function 1, we have to impose some restriction on the range and domain. So we will choose some values for that the function become the 1 also 1 and onto both. So we will choose some values for this for that the function become the inverse. So for this some fixed values of the range and domain, this function will become 1 and onto. Then we can find the inverse of the given function. Okay. So see here, what are those values? We will see here. So to find the sine inverse of x, the function must be 1 and onto. If it is not 1 and onto, then we can't find the inverse of this function. That's why we are making some restriction to the range and domain values. Here in the second graph, this graph is sine inverse of x graph. This graph is obtained by interchanging x and y values x and by interchanging the values on x and y axis. See here, this is y axis -1 and 1. It is the range for x sin x. But here x we are taking this one 1 and -1. Then it become 1 and -1 become domain for sin inverse of x, and the real values, all real values become range for the sin inverse of x. See here, for sin x we are having, for sin x we are having domain and range. Domain is R and range is -1 to 1. Okay, if you are taking C, it is a real number and it is -1 to 1, and our function sign is like this, sin x. But for sin inverse of x, it will goes like this, from -1 to 1 to range R. Okay, so the graph is this. This graph is obtained, sin inverse of x graph is obtained by interchanging the xy values, by changing values in x and y axis. That means, suppose a function in AB on the xy plane become B comma A on yx plane. Okay, by interchanging this point, we can draw this graph. Okay, so for sin inverse of x, what will be the range and domain? Domain will become -1 to 1, and range is the set of real numbers R. Okay, if you are taking this, then also this function will not become 1. Okay, because on x-axis we are having different values, or sorry, on y-axis we are having different values. So for different values we will having same image 1 and -1. So we have to restrict this. To make this function 1, we have to restrict some values so that for we will make some restriction. So we have to take some values for which the function become 1. So here I am taking the values +π/2 to -π/2, for which we are having same image. Then the function will become 1. For this value, the function will become 1. How? By putting sine of x by -1, we will get y value as π/2, because we are taking inverse. And for sine inverse of 1, sine inverse of x is nothing but π/2. So for +1, we are having π/2 value. For -1, we will get -π/2 values. Okay, that's why we are taking restriction to -π/2 to +π/2. Then the range will become, for sin inverse of x, the range will become -π/2 cos interval to domain is -π1 and +1, and range is π/2 to +π/2 close interval, means including minus and plus pi by 2. Okay, so by taking these values, we have makes restricted. We have taken fixed value in the range and domain. We have made this function 1 1. Okay, so we can also consider some another values for which this function will become 1 1. See here, for pi by 2 to minus pi by 2, this will become inverse. Okay, 1 1, sorry, 1 1. And now we can consider range. Domain is our domain. We are having minus 1 to 1. It is same, and range is for minus pi by 2 and pi by 2 we have taken. Now consider the value minus plus pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. For this also the function will, for this value also the function will become 1 1. Okay, and what about here? Minus 3 pi by 2 to minus pi by 2. Minus 3 pi by 2 to minus pi by 2. Then also the function become the 1 1 function. If it will become a 1 1 function, then we can find the inverse of the given trigonometric function sin x. Okay. Once again I will explain, I will repeat. Here we are having natural domain and range of sin x's. X values are real numbers and y values are plus 1 to minus 1, and we can say that the graph is lies in between plus and minus values. Okay, if we substitute any values from x, and you can see all x values are real numbers and y values are minus 1 to plus 1. Okay, if we take any value of x from the real number, we will get plus 1 and minus 1 values on the y-axis. That's why we are taking minus 1 to plus 1 is the range of this sin of x. Okay, to find the inverse of sin of x, now we have to check whether the given function is 1 1 or 2. By putting different values on the x-axis, if you are taking sin pi by 2, we will get plus 1. If you are taking sin pi by 2, we will get plus 1 values. Here also on sin minus 3 pi by 2, we will get plus 1 values. So we are having for different values of x, we are having same value 1. That means it will not, it is not a 1 1 function, because for 1 1 every value on the x-axis, x or the for domain, the image will be different. Okay, here the image is same, so it is not a 1 1 function, but it is known to, because for every value on the y-axis we are having image on the x-axis. Okay, we are having different image for the x-axis. Now we have to find the inverse of, anyhow we have to find the inverse of sine. So that we will make some restriction, we will impose some restriction, so that the function become 1 1. So we will choose some values of the range and domain so that the function will become 1 1. Then we can find the inverse of the given function. Okay, so we will, for the fixed values, for some fixed values of range and domain, we can find the inverse of the given function. Okay, so here after, for drawing the graph of sin inverse of x, we have to interchange the point on x-axis and y-axis. Consider a point A and B on the xy plane. Suppose we are having a point, I will show you. A point AB on the x and y-axis will become B comma A on y and x-axis. By this, okay, this one is just for your understanding. So by this we have interchanging point, domain become range and range will become domain. So again after drawing this, again it is not a 1 1 function. So we have taken some, chosen some values for example pi by 2 plus pi by 2 minus pi by 2, for which this function will become 1 1. So for plus pi by 2 and minus pi by 2, it will become a 1 1 function. So another values also we will get. For pi by 2 to 3 pi by 2, it will become 1 1 function. For minus 3 pi by 2 to minus pi by 2, it will become a 1 1 function. Okay. So, but we have to consider only, write this, it is a very important. We have to consider only pi by 2 to minus pi by 2. Just this value we have to take, because it is a principal value of branch, means it is a principal value for the sine of x. Okay, we have to consider only this value. We can take another value also, but it is the rule. According to that rule, we have to take only pi by 2 and minus pi by 2 values for finding the inverse of sine x, inverse of x. Okay, so in the next I will take the graph for y is equal to cos of x. Okay, the next, for next I will take the graph for y is equal to cos of x.